Hi everyone, I'm Ginstavin Ibrahim and this is my presentation about polymers. And before that, what is polymers? Polymer. A polymer is a substance composed of molecules with a large molecular mass of repeating structural units or monomers connected by covalent chemical. In addition, polymers are long-chain giant organic molecules are assembled from many smaller molecules contain monomers. Polymers consist of many repeating monomers unit in long term of chain. A polymer is analogous to a necklace made from many small beads. Another common name for many synthetic polymers is plastic, which comes from the Greek word plastikos, suitable for molding or shaping. Many objects in daily use, from packaging, wrapping, and building materials, include half of all polymers synthesis unit in the chain of which our polymers is made. Types of polymers. Polythene. The first commercial use polymers is all the simplest and the common polythene. Its systematic name is polyethylene, meaning it is a polymer made for the monomer ethene. Ethene is a small molecule containing two atoms linked by a double band and four hydrogen atoms, two bounded to each carbon. The second type of polymers, free electron. When ethene is subjected to high temperature and pressure or reacted in the presence of a catalyst, one of the bonds in the double band is broken. Each of the carbon atoms then has a free electron, which can form a covalent bond by pairing with another free electron. If other ethene molecules are present, the double bond in one of them can break, and the free electron on one of the carbon can combine with another on the original molecule. As this continues, a long chain of carbon atoms bonded to one another by a single covalent bond form. Each carbon atom has two hydrogen atoms bonded to it. The third type of polymers, polypropylene. Other polymers can be made in this way. Polypropylene is very similar to polyethylene. It is made from propene, which has three carbon atoms, two of which are joined by a double bond. When it reacts to become a polymerizes, the long chain is similar to polyethylene, except that every other carbon atom has methyl group attached to it. Varied uses. The properties of this type of polymer depend on the regularity of the arrangement of chains. If they are lined up in a regular way, they are strong, hard material. If they are more irregular or there are more side chains on the molecule, they are flexible. Amide linkage. One of the most common molecules in biochemistry is a type of polymers called proteins. They are made up from monomers known as amino acids, and they are joined by an amide linkage. These linkages are made by a carboxylic acid group reacting with an amine group, forming the linkage and eliminating water. This linkage is basis of another type of synthetic polymers, the nylon. nylon, whereas the team used monomers with both a carboxylic acid and an amine in the same molecule. Nylons are made using two types of monomers. These are dicarboxylic acid and diamine. The first nylon cytidine used one monomer with a chain of 4 carbons with a carboxylic acid group on each end and another monomer with a 6 carbon chain with an amine group on each end. This produces a polymer with repeating units of 6 carbon joined amine linkage, but alternative reverse. These polymers is nylon 6.6. Nylon are mainly used as fabrics for clothing and also other hard parts in light engineering. Polyurethane. A further important group of polymers are polyurethanes. These are very similar to nylons, but are formed by reacting alcohols with isocyanates and have an amide linkage with additional oxygen atom in the chain. These polymers are softer and more elastic than nylon and are used as a substitute for rubber and elastic and lyra. Last, polyester. The final type of polymers will be deal with in this article are the polyester. The ester linkage is a carboxylic acid group where the hydrogen has been replaced by the carbon of another organic group. Polyester are widely used as fabrics for cloths and also for many drink bottles. They are also used to make thin film for applications such as videotape.
Here are the example of degree of polymerization.
Staticity, planar representation of polypropylene polymers. Functionality, the number of reactive sites present in the monomer is called functionality. Classification of polymers. Number 1, homopolymers. Consist of chain with identical bonding linkages to each monomer unit. This usually implies that the polymer is made from all identical monomer molecules. This may be presented as classification of polymers. Copolymers consist of chain with 2 or more linkages, usually implying 2 or more different types of monomers. Polymers are further classified by the reaction mode of polymerization. These include: first, addition polymers. The monomers molecules bond to each other with the loss of any other atom. Alkane monomers are the biggest group of polymers in this class. The second, condensation of polymers. Usually, 2 different monomers combine with the loss of a small molecule, usually water. Polyesters and polyamides or nylon are in this class of polymers. Polyurethane foam in graphene. Classification based upon the physical property related to heating. Thermoplastics. Plastic that soften when heated and become firm again when cold. This is the more popular type of plastic because the heating and cooling may be repeated. Thermoset. Plastic that soften when heated and can be molded, but harden permanently. They will decompose which reheated. An example is bakelite, which is used in toaster, handle for pots and pans, dishes, electrical outlet, and billiard balls. And now, here are the properties of polymers. The physical properties of polymers such as the strength and flexibility depend on chain length. In general, the longer the chain, the stronger the polymer. Next, side groups. Polymer side groups give stronger attraction between polymer chain, making the polymer stronger. The third one, branching. Third trait. Unbranched chains can pack together more closely than highly branched chains, giving polymers that are more crystalline and therefore stronger. And last, cross-linking. If polymer chains are linked together extensively by covalent bonds, the polymer is harder and most difficult to melt. Structure and properties of polymers: heat capacity, thermal expansion, crystallinity, permeability, elastic modulus, tensile strength. Strength of polymers. In general, the longer the polymer chain, the stronger the polymers. There are two reasons for this. Longer chains are more tangled. Second, there are more intermolecular force between the chain because there are more points of contact. These forces, however, are quite weak for polyethylene. Areas in polymer where the chains are closely packed in a regular way are said to be crystalline. The percentage of crystallinity in a polymer is very important in determining its properties. The more crystalline the polymers, the stronger and the less flexible it becomes. Strength of polymers. When a polymer is stretched, cold drawn, a neck forms in the neck, the polymer chain line up producing a more crystalline region. Cold drawing leads to an increase in strength. The first polyethylene, which was made the main chain, which were branched. This resulted in a relatively disorganized structure of low strength and density. This was called low density polyethylene or LDPE. In the crystalline form, the metal group all have the same orientation along the chain. This is called the isostatic form. In the amorphous form, the metal group are randomly orientated. This is called the atactic form. Polymers with a regular structure are said to be stereoregular. Application of polymers. Polymeric materials are used in and on soil group aeration to provide mold and promote plant growth and health. and health. Medicine. Many biomaterials, especially heart, valve replacement, and blood vessels are made of polymers like Dacron, Teflon, and polyurethane. Consumer science. Plastic containers of all shapes and sizes are lightweight and economical, less expensive than the more traditional containers. Clothing, floor covering, garbage disposal bags, and packaging are other polymers application. Application of polymers. Industry. Automobile parts, windshields for fighter planes, pipes, tank, packaging materials, insulation, wood substitutes, adhesive, matrix for composites, and elastomers are all polymers applications used in the industrial market. Sports. Playground equipment, various balls, golf clubs, swimming pools, and protective helmets are often produced from polymers.